Underfloor air distribution. Welcome to the Underfloor air distribution section of the Price training module. Underfloor air distribution provides an effective method of obtaining excellent air quality and thermal comfort in the occupied space. It is ideal for places such as office buildings, theaters, auditoriums, libraries, and courtrooms, to name a few. In this unit, we will explore the concept behind underfloor air distribution, its benefits, and how it compares to other air distribution systems. We'll look at some design considerations and learn the importance of properly configuring a room in order to deliver air in an efficient way. Once we understand that, we'll take a look at Price's underfloor products, which can cover a wide range of applications. The concept. A raised floor system can provide space for network cables, telephone lines, and video cables to be easily routed underneath the floor. What's more, diffusers can be installed in the floor tiles, and the raised floor system can be used as an efficient and flexible method of air distribution. In the event the room occupancy layout is changed, the air distribution can be customized as required since the floor tiles are interchangeable. Underfloor air distribution, also referred to as UFAD, works in many ways like displacement ventilation. Displacement ventilation systems typically introduce air at low velocities and low levels, which cause minimal induction and mixing within the space. Heat sources such as people, computers, lighting, and electrical equipment located in the room generate thermal plumes. These thermal plumes lift the air through the occupied zone and carry with it contaminants and heat to high-level returns. By doing so, the air quality in the occupied zone is generally superior to that achieved with mixing ventilation. A conventional mixing system usually introduces cool supply air at high velocities at or near ceiling level. The high outlet velocity causes induction of room air, thereby rapidly mixing the supply air with the room air. This mixing effect minimizes stratification in the room. For more information on displacement ventilation or mixing ventilation systems, please explore the basics of HVAC, displacement ventilation, and space air diffusion sections of the Price training module. In an underfloor air distribution system, the air is supplied at a higher velocity than that of displacement ventilation, typically at 65 degrees Fahrenheit or higher in cooling mode. This is done through small-sized outlets that allow for mixing in the lower portion of the room and stratification above the occupants. The underfloor air distribution system creates a general upward flow of air in the space which, working with the natural buoyancy of the heat loads, allows an effective removal of heat, pollutants, and odors. Together with the room air, the pollutants are exhausted through the building return system located at high level in the space. Underfloor air distribution provides an effective method of obtaining good air quality and thermal comfort in the occupied space. It offers excellent occupant comfort by allowing occupants to control their local environment with adjustable diffusers, making it ideal for places such as office buildings, theaters, server rooms, libraries, and courtrooms, to name a few. Before we can discuss the airflow patterns, we must understand what the occupied zone is. The occupied zone is usually defined as the area within 6 feet of the floor and not within 1 foot of the boundaries of the space, walls, etc. As this is the area of occupancy, it is desirable to avoid excessive draft velocities and temperature differences within this space. When supplying air to the occupied zone, it's important to consider ASHRAE 55. Thermal environmental conditions for human occupancy specifies the combination of indoor space environment and personal factors that will produce thermal comfort conditions acceptable to 80% or more of the occupants within a space. We cannot introduce air at temperatures typical of an overhead system because it would cause increased temperature variations in the occupied zone, and as we are supplying air through an underfloor plenum, the floor would be very cold. It would act as a radiant cooling panel, and conduction or leakage would cause feet to be very cold. Therefore, UFAD systems typically have a higher supply air temperature and return air temperature than mixing systems. Now that you understand the basic concept behind underfloor air distribution, let's take a closer look at its airflow patterns. In general, there are 2 types of flow patterns available with round floor: turbulent flow and displacement flow. As you'll see, these types of flow have different velocity distribution and varying effects on the vertical temperature gradient of the room. An underfloor air distribution system uses floor twist outlets to generate a turbulent airflow. These turbulent flow diffusers discharge conditioned supply air at elevated velocity, around 400 to 800 feet per minute, at floor level. The discharge is a vertical swirling pattern which rapidly induces the room air. This turbulence enhances the induction of room air and allows occupants to be in close proximity to the supply air jet without feeling drafts. In a properly designed underfloor air distribution system, the supply air should be fully mixed with the room air within 6 feet above the floor, forming a stratification layer at this point. This way, heat and pollutant collects at high level and conditioned air remains in the occupied zone. The floor twist outlet is normally inserted in the floor tiles of the conventional raised floor system. A distributor basket may be inserted under the air outlet to trap solid objects such as coins and paper clips that may fall into the air outlets. In addition, some diffusers allow the volume and direction of the local air supply to be controlled by the occupant, allowing their local environment to be individually controlled. Displacement ventilation results from a horizontal radial discharge of supply air from the floor outlet. The outlet velocities are also lower than that of turbulent flow at around 200 to 400 feet per minute, and as the air distributes in the radial pattern, the air velocity drops off rapidly and slows to a draft-free velocity of around 70 feet per minute at about 1 foot from the diffuser. The displacement outlet slots are designed to provide very limited vertical air movement directly over the diffuser face and is typically less than 8 inches. The supply air rapidly loses its momentum and spreads in a horizontal circular pattern along the floor due to gravity, since the supply air is slightly denser than the room air. As a result of the lower momentum, displacement air distribution does not induce significant amounts of room air. All heat sources have a naturally occurring thermal plume. This thermal plume, often referred to as natural convection, pulls cooler air from the floor and distributes it upward due to the upward motion of the warmer air that the heat source is generating. At all heat sources in the occupied zone of the room, such as PCs, occupants, or other equipment, the cool supply air is drawn upward at a very low velocity, penetrates the occupied zone, and reaches into the ceiling zone where it is exhausted. This upward motion of the air forms a vertical temperature stratification. The upflow, however, is determined only by buoyancy and not by inertial force. Therefore, the flow velocities of the rising air are extremely low. As a consequence, the vertical temperature gradient is much more pronounced than that of turbulent flow. Benefits. The reduced cost of churn, or room reconfiguration, is an important factor when considering underfloor air distribution. Since the floor tiles are interchangeable, the underfloor air distribution system can be customized as required. In the event the room occupancy layout is changed, reconfiguration is relatively efficient and does not require changing the entire building, resulting in dramatic savings. Underfloor air distribution has many benefits which can be credited towards achieving LEED certification. LEED stands for Leadership in Energy and Environmental Design and is a national standard defined by the U.S. Green Building Council. The program is based on these primary categories: sustainable sites, water efficiency, materials and resources, energy and atmosphere, indoor environmental quality, and innovation and design process. Points and credits are awarded for various items in each of these categories. Buildings are deemed LEED certified buildings if they earn a certain number of points. Underfloor air distribution can help achieve LEED points in several ways. Efficient chiller performance. Due to the higher supply air temperature and stratification above the mixing zone, the return air temperature of a UFAD system is substantially higher than a mixing system. The increased return air temperature and supply air temperature contribute to an increased chiller coefficient of performance, or COP, providing energy savings. More free cooling. The higher supply air temperatures associated with underfloor air distribution allow for an extended free cooling band. This means that more hours during the day are available for the ventilation system to use outdoor air to cool the building. This leads to increased use of the economizer, an excellent way to reduce energy consumption. ECM technology. UFAD terminals are available with electronically commutated motors, or ECM, which can provide energy savings of up to 50 to 60%. Furthermore, the ECM motor life is extended due to its low operating temperature and ball-bearing design. These combine to offer a great opportunity for lead points. Lower fan horsepower. Further energy savings are realized with the reduced air pressure required for the system. This reduced air pressure is a direct result of the lower fan horsepower needed to supply the lower density ductwork. UFAD installations typically work at a plenum pressure of less than 0.1 inches water gauge, reducing duct static pressure and the fan requirements for the system. Reducing the fan requirements usually means smaller equipment and therefore a reduction in initial capital cost of the HVAC system. Occupant comfort. Some UFAD diffusers allow the volume and direction of the local air supply to be controlled by the occupant, allowing their local environment to be individually controlled. Thermal comfort. In an underfloor air distribution system, the occupied zone is completely mixed, creating an isothermal environment due to the extremely low air velocities, typically less than 20 feet per minute. There's very little temperature difference between a person's head and ankle. To summarize, underfloor air distribution provides many benefits, such as a more efficient chiller performance, more free cooling, ECM technology, lower fan horsepower, occupant comfort, and thermal comfort for reducing energy consumption and earning valuable lead points. Ventilation effectiveness is another area where underfloor air distribution excels. Ventilation effectiveness can be defined as how effectively airborne contaminants are removed from a room. It can be determined by comparing the level of contaminants in the occupied zone to the contaminants in the exhaust leaving the room. Basically, if there are more contaminants in the return and less in the room, you have a high level of ventilation effectiveness. If the concentration of contaminants in the return is equal to the concentration of contaminants in the occupied zone, the ventilation effectiveness equals 1. If the concentration of contaminants at the return is greater than the concentration of contaminants in the occupied zone, the ventilation effectiveness is greater than 1. Ventilation effectiveness in a mixing system is typically measured at about 0.8. Underfloor air distribution systems, with their low-level supply and high-level return, will typically have a ventilation effectiveness of 1 to 1.9, providing superior indoor air quality by removing contaminants and supplying clean and conditioned air more effectively. Design considerations. Along with these benefits are various design considerations that the HVAC designer has to keep in mind. In the following section, we will discuss some of these design considerations and how to get the best performance possible and superior air quality from your underfloor air distribution system. Underfloor air supply methods. An underfloor air distribution system has two general methods of supplying air. One method is to use a pressurized floor plenum, and the second method is to use a ducted supply to each of the air outlets, similar to an overhead system. The raised floor system can be pressurized, and this serves as a very efficient means of distributing air within the zone. In most cases, the pressurized plenum method of supplying air is preferred due to the following advantages. Lower installation costs. The supply air is fed directly from the air handling unit to the pressurized plenum. No other branches of ductwork are required. Improved balancing of supply air volume rates. The underfloor system is self-balancing. If an outlet is covered, the system will rebalance itself. Less noise. The vast underfloor plenum helps to attenuate any sounds, and the chance of sound transfer from outlet to outlet is reduced. Easier relocation of floor outlets. Relocating of outlets is simply a matter of rearranging the tiles of the underfloor system. The pressurized plenum means that there is no ductwork to be rerouted. In an underfloor pressurized plenum system, the air being supplied is affected by the height of the plenum. The higher a plenum is, the better and more evenly the air is distributed within the plenum. The minimum clearance required for airflow in a pressurized floor plenum is 3 inches. With this clearance, a single supply duct can feed a plenum area of 500 square feet. With a plenum height of 8 inches, a single supply duct can supply an area of up to 3,000 square feet. Multiple supply feeds would be required for an area exceeding 3,000 square feet. In actual practice, underfloor system plenum heights are generally between 12 and 18 inches. An advantage of greater plenum heights is that it provides clearance for other equipment, such as fan terminals, electrical, and water systems. Plenum pressures are typically maintained in the range of 0.05 inches to 0.1 inches water gauge. The pressure of the plenum is controlled by a pressure controller relative to the space and varies the airflow by either a variable volume air handling unit or a modulating damper. The second method of supplying an underfloor air distribution system is to duct each of the underfloor outlets similar to a conventional overhead system. This method has the following advantages. Lower energy exchange with the floor masses. Since the air is ducted, it doesn't come in contact with the floor slab. It is recommended that main ducts be run in public areas or beneath walkways when laying out a ducted supply system for an underfloor air distribution system. If an office layout is rearranged, only rerouting the branch ductwork is required. The main ducts beneath the corridors do not have to be modified. The height of the underfloor plenum is another important factor to be considered when laying out an underfloor system. Enough space must be left between the ductwork and the underside of the raised floor to allow for wiring, piping, and conduits to easily pass over the ductwork. Ductwork is typically installed on the floor and is not suspended from the underside of the raised floor. When designing an underfloor system that uses a pressurized floor plenum, residency time of the supply air is an important factor. While in the plenum, the supply air is affected by the room above and below it. Heat can be transferred through the floor tiles from the room above or through the slab heated by return air from the floor below. The longer the supply air is in the plenum before entering the zone, the higher the exit temperature will be. What's more, wide temperature variations throughout the plenum and diffusers can occur, ultimately leading to discomfort in the occupied zone. This problem could be reduced with careful plenum design. The residency time and thermal decay is related to the airflow patterns in the plenum. The farther the air has to travel in the plenum, the longer it takes to be fed to the space. It is recommended that the air be spread out when it's discharged into the plenum by using inlet directional vanes or multiple points of injection. This way, the formation of circular patterns in the plenum can be avoided. It is important to promote the even distribution of air in the plenum and the ability to direct more air into local areas of resistance so that consistency in airflow can be achieved. Rarely do all areas of a building experience the same heating and cooling loads at the same time. Typically, there are up to 6 distinct zones in a building. There can be 4 exterior or perimeter zones, 1 facing each direction, at least 1 interior zone, and the special zones. Special zones are zones with intermittent occupancy, such as meeting rooms and conference rooms. Each of these zones can experience vastly different loads at any one time, and therefore must be treated separately. Control zones are determined in the same way as with conventional overhead air supply systems. Control zones are made up of rooms or groups of rooms with similar load characteristics. The room temperature in each zone will be individually controlled. This can be done by either varying the supply air temperature or varying the supply air volume to the space. Interior zones typically have relatively stable loads. As a result, a constant volume supply can often be used. A typical interior zone consists of constant volume turbulent floor twist outlets installed in a large common plenum space. A distributor basket and damper can be provided for individual volume and directional control, and in some cases can be adjusted by rotating the face of the floor outlet itself. In this application, the entire plenum space is treated as one zone, and under fluctuating loads, the amount of air delivered to the space is regulated by the relative pressure in the plenum, modulated by a single control point. This method is preferred for most applications as it is the most economical. It is important to ensure that the large zones maintain similar loads throughout to reduce discomfort. In some cases, dividing an open plenum into several zones is desirable. Variable air volume control is possible with the use of devices installed under the diffuser or with the use of a variable volume basket. This system allows the zone to operate independently in response to the local load controlled by a thermostat. Exterior perimeter zones. Perimeter zones can experience rapid fluctuations in loading. There are several options available to quickly satisfy these rapid changes. 1. Linear variable volume air outlets, model LFG-VC, are installed along the perimeter. These air outlets are controlled by a thermostat located in the zone, modulating the opening and closing of dampers found in each diffuser to satisfy the cooling load. Advantages with this option are easy installation, minimal installation cost, and since there's no ducting, easy reconfiguration. 2. The control zone is formed using ducted linear air outlets model LFGF, which are connected to a variable volume fan-powered terminal unit. This terminal unit is controlled by a thermostat located in the zone, increasing or decreasing the supply airflow in response to the thermostat signal to satisfy the demand. Supplemental heat, if required, is provided by a hot water coil or electric coil on the terminal unit. The VAV fan-powered terminal unit allows for a rapid response to any demand from the control zone. It's also possible to heat in this configuration. An advantage with this option is that you can do both heating and cooling, and there's a rapid response to fluctuations in loads. However, since it is ducted, there is an increased installation cost, and it's more difficult to reconfigure. 3. A plenum partition is a sealed-off part of the plenum formed by installing a rigid plenum divider. Within the underfloor plenum, a physical partition is installed around the control zone, forming a subplenum. This subplenum is supplied by a variable volume fan-powered terminal unit. This terminal unit is controlled by a thermostat located in the zone, increasing or decreasing the supply of airflow in response to the thermostat signal to satisfy the demand. Non-ducted linear outlets, model LFGC, are used to discharge air into the control zone. Supplemental heat, if required, is provided by a hot water coil or electric coil on the terminal unit. The variable volume fan power terminal unit allows for a rapid response to any demand from the control zone. The LFG-HC is also available, and it allows for heating and cooling operation. Advantages with this option are lower installation costs, it can do both heating and cooling, and it is versatile. Limitations in this system exist, in that it is generally discouraged to heat the floor slab, but for small zones it's acceptable. Latency issues also exist with this system due to energy storage in the floor slab. 4. A control zone is formed using a variable volume fan-powered terminal unit controlled by the room thermostat. The terminal unit is ducted to variable volume round floor boots and linear floor grills. The terminal units have ducted boots on both the inlet and discharge. In cooling mode, the terminal unit is de-energized, and all the boots are fed by the pressurized floor plenum supplying cool supply air into the control zone. In the heating mode, the plenum inlets are dampered to a minimum position, and the fan-powered terminal unit is energized. Air is drawn from the control zone through the boot ducted to the inlet side of the terminal unit. It then passes through the terminal unit and heating coil and is discharged back into the control zone through the boots on the discharge side of the terminal unit. This allows air to be used for heat, reducing the interior energy requirement to heat the perimeter zone. An advantage of this option is that it uses return air to heat the zone, and there's a rapid response to fluctuations in loads. Special zones, such as conference rooms, meeting rooms, and interior offices can experience wide load swings due to intermittent occupancy or equipment operation. The air distribution system must be able to satisfy these load swings while maintaining comfort levels in all areas. There are several options available to address special zones. 1. A control zone is formed by using DBV non-ducted variable volume baskets, model RFTD with DBV, controlled from the room thermostat. These baskets are supplied from the pressurized floor plenum. Advantages of this option are easy installation, minimal installation cost, flexibility, and since there is no ducting, easy reconfiguration. 2. A control zone is formed using a variable volume fan-powered terminal unit controlled by a thermostat located in the zone. The fan terminal is ducted to the floor outlets, model RFTD with RFBF boot, and supplies cooled plenum air to quickly satisfy the demand. It's also possible to heat in this configuration. Advantages with this option is that you can do both heating and cooling, and there is a rapid response to fluctuations in loads. However, since it is ducted, there's an increased installation cost, and it is less flexible. 3. A control zone is formed by installing physical plenum partitions in the plenum, forming a subplenum under the control zone. A variable volume fan-powered terminal unit is used to pressurize the subplenum in response to a signal from a control thermostat located in the zone. Non-ducted air outlets, model RFTD with DB damper, discharge air from the subplenum into the control zone to quickly satisfy the demand. Upon a demand for cooling, the fan will energize and pressurize the plenum. Upon a call for heating, a heating coil may be energized. Advantages with this option are lower installation costs, it can do both heating and cooling, and it is versatile. Limitations in this system exist in that it is generally discouraged to heat the floor slab, but for small zones it's acceptable. In order for the underfloor air distribution system to perform to the design specifications, it's important to reduce the amount of leakage from the outside air into the floor plenum as much as possible. Due to the relative low pressure of the floor plenum, usually not higher than 0.1 inches water gauge, good construction materials and good installation generally provide adequate protection. It is recommended that insulation equal to the height of the floor plenum be installed along the perimeter walls. Furthermore, it is essential that partitions extend from the slab to the plenum floor in order to effectively seal the plenum. Having said that, leakage from the plenum space to the room is unavoidable, but can be mitigated by the floor configuration. This table, page 43 of the Price Underfloor and Displacement Ventilation Systems catalog, shows the leakage of a standard floor with 0.05 inches water gauge and 0.1 inches water gauge of pressure. In this table, no carpet refers to a raised floor installed without any room side finishing. Aligned refers to the carpet tiles, equal in size to the floor tiles, having their seams directly above the seams of the floor tiles. Offset refers to the carpet tile, equal in size to the floor tiles, having their seams offset in both directions from the floor tiles. It should be noted that the way the carpet tiles are arranged can impact the ease of churn or occupant relocation in the future, with the aligned configuration requiring the removal of only one carpet tile to access a floor tile, making diffuser relocation easier. Leakage is generally more important than ease of churn, and installations typically use the offset configuration. Please note that this leakage rate data is for standard raised flooring, not raised flooring with a gasket or other sealing method. Installing underfloor partitions from the floor slab to the underside of the raised floor will isolate special rooms, such as conference rooms. Due to the low amount of pressure within the floor plenum, leakage from zone to zone is of little concern, but should be controlled where possible. Another crucial way to minimize leakage in the plenum space is to ensure that the drywall installations for each room do not just stop at the floor panel level, but reach all the way down to the floor slab. When designing an underfloor system, the leakage rate and its effects should be taken into account in order to properly select your diffuser. As with ceiling or wall air outlets, the question is whether floor air outlets transmit speech and other noises to adjacent rooms. In other words, is it possible to hear the conversations in the next room due to a sound transmission path through the air outlets? In a building with ductwork installations, studies have shown that the loss from room to room is between 43 and 60 decibels. Sound transmissions reaching the adjacent room are generally negligible. In a building using a pressurized floor plenum, the sound diffuses in the floor plenum. Secondly, there is further sound reduction through the floor outlets. Tests have shown that sound attenuation is in the order of 40 to 80 decibels. In conclusion, sound transmission through floor air outlets is negligible. Additional sound attenuation measures are rarely needed to improve the reduction of speech transmission between two adjacent rooms. For more information, you can refer to the noise control section of the Price Training module. Due to the higher temperatures in use with underfloor air distribution, humidity may be a consideration in certain regions. The underfloor air distribution system has a supply air temperature of approximately 65 degrees Fahrenheit, as opposed to the 55 degrees Fahrenheit found in conventional mixing systems. If the cooling coil cooled outdoor air to this level, less moisture would be extracted at the cooling coil and humidity could rise to unsuitable levels. In order to achieve proper dehumidification with underfloor air distribution systems, we can cool the circulated air to 55 degrees Fahrenheit, then temper it to the desired air temperature of 65 degrees Fahrenheit before introducing it into the environment. This is most commonly accomplished by mixing the warm filtered return air with the conditioned air at the air handler, known as side stream bypass, or with a constant volume terminal unit at the zone level. So far, we've taken a look at how underfloor air distribution works and explored the concept behind underfloor air distribution, how it compares to traditional mixing systems, the benefits of underfloor air distribution, the two different types of outlet flows, turbulent and displacement flow, the two air supply methods, pressurized plenum and ducted supply, and various design considerations. Next, we'll take a look at Price's extensive line of products available in underfloor air distribution. Price's underfloor products. In this interactive section, you have the unique opportunity of approaching Price's underfloor products in two ways. By clicking on the Products tab, you can view all of Price's underfloor products in a mini catalog, or click on Applications to see them being used in different locations. The Price underfloor air distribution system consists of a full range of components including round floor diffusers, round floor boots, linear floor grills, modulating controllers, fan terminal units, and variable volume baskets, which may be combined to suit a variety of underfloor applications. Click on any one of these to learn more about their features. Round floor diffusers. The Price line of round floor diffusers by Krantz provide an excellent means for the efficient, attractive, and safe supply of air through underfloor systems. These diffusers offer patterns ranging from high induction vertical twist patterns to low turbulence horizontal displacement. A full line of mounting options and damper devices are available to suit your application. Round floor boot. The Price line of round floor boots allows for the supply and control of warm and cold supply air from raised floor systems. These boots increase the versatility of the round floor diffusers and can be used in conjunction with Price's line of underfloor controllers. The steel plenum for ducting and damper control has an overall height of less than 9.5 inches. 3 configurations are available for specific applications: the RFB-F, the RFB-VC, and the RFB-HC. Linear floor grills. The Price line of linear floor grills allows for the supply and control of warm and cold supply air from raised floor systems. They are available with deflector vanes which allow them to service a larger perimeter space and reduce the possibility of recirculating upper zone air back into the occupied zone. 4 configurations are available with different options, such as VAV cooling and constant volume heating, modulating damper with electronic actuator, plenum for debris collection, and more. The 4 configurations for the linear floor grills are the LFG-HC, the LFG-VC, the LFG-C, and the LFG-F. Underfloor Modulating Controller. The Price Underfloor Modulating Controller series allows control over the underfloor air delivery applications. Components of the Price Underfloor air distribution system have been specially designed for easy installation and system connectivity. Diffusers and linear floor grills do not require field assembly and can often be dropped in place after the floor tiles have been installed. System control cabling is easily installed with modular plug connectors and plenum-rated cabling provided with each LFG and RFB unit, not to mention DBV connectivity. Parallel jacks on each component add complete flexibility to system design, enabling multiple units to be daisy-chained together. The Price Underfloor Modulating Controller can handle up to 12 variable volume LFG or RFB units, as well as the terminal unit fan and heater element. Underfloor Fan Terminal. The Price Underfloor Fan Terminal series supplies conditioned or heated air to the occupied zone. Their compact configuration makes them easy to install in today's raised floor systems. Furthermore, they are provided with the latest ECM motor technology, which provide energy efficiency, longer lifespan, low operating temperatures, wider operating range, variable fan flow, and are programmable. Furthermore, all of Price's underfloor fan terminals are designed to fit inside the floor stilts. Variable Volume Basket. The Variable Volume Basket, DBV, is for use with Price's extensive line of 8-inch round floor diffusers. The DBV allows for even distribution of supply air through the round floor diffuser core while integrating into a VAV cooling system. With an integral motor and damper, the DBV basket is ideal for VAV cooling applications. The black plastic basket prevents see-through to the building floor and is also used to catch debris that falls through the diffuser face. The unit is installed from the room side, slipping into the diffuser frame for easy installation. This combined with modular RJ12 jacks makes installation and wiring quick and simple. Click on any one of these to learn more about their features. Underfloor air distribution provides an effective method of obtaining good air quality and thermal comfort in the occupied space. It offers excellent occupant comfort, making it ideal for places such as office buildings, theaters, server rooms, and libraries, to name a few. Click on any one of the following examples to see underfloor air distribution in various applications. See if you can spot all of Price's underfloor products. Courtroom. The ease of reconfiguration and low noise levels makes underfloor ideal for places such as courtrooms. Hotel. Underfloor products can be used with raised floor systems for seamless integration with hotel lobbies. Boardroom. Underfloor products can be used with raised floor systems for inconspicuous integration with offices and boardrooms. Office. The individual control and ease of relocation unique to underfloor diffusers makes them the right choice for offices. School. Underfloor products are a very quiet and flexible system that can be easily used in secondary or college classrooms. Theater. Underfloor displacement diffusers are effective in areas with high ceilings, such as theaters. The diffusers can even be installed under the seats. Server room. In places like this server room, underfloor diffusers lift the heat and contaminants up and away from the equipment and into high-level returns near the ceilings. Library. The extremely quiet underfloor diffuser is an efficient supply system for places with high ceilings such as libraries. Conclusion. We hope that you've enjoyed this look at underfloor air distribution. We've explored many aspects of underfloor air distribution, from concepts to benefits to design considerations. We've also seen that the Price underfloor air distribution system consists of a full range of components, including round floor diffusers, round floor boots, linear floor grills, modulating controllers, and fan terminal units, which may be combined to suit a variety of underfloor applications. For more in-depth information on this topic, you can always refer to the price catalog. Be sure to explore the rest of the units in this price training module to learn more about air distribution as well as the extensive line of price products available. You can contact your local price representative or visit our website at www.price-hvac.com.